we're now going to talk a little bit about function notation and finding values of functions. Alright, so our first thing to talk about is function notation. We say that a function f of x, this is red, f of x, is the correct notation to identify a function. We call the f the name of the function, and we call the x the input or the independent variable. It's also called the argument of the function. It's where we get to make up our mind of what we are. So, like we were competing or discussing something, the argument is what dictates what the output is going to be. Now, quite often the name doubles as the dependent variable, but in a few cases we'll actually specify and say that y equals f of x, in which case y would be the dependent variable. So whenever we're going to graph a function, we assume that the function is representing y as our dependent variable. And we call y the dependent variable because its value depends on what the function does to the input. X is the input independent variable because you get to pick x. You get to plug whatever you need to in. Now, one more thing to specify is that f of x is the value of f at x, meaning when I see f of x, that's the output value of the function. So let's look at a couple of examples, and let's actually use f of x equals at 2x squared minus x, and let's evaluate. So when we evaluate, we're going to be given an x, say f of 2. And then this way we specify what our value is. So this is x. And wherever I see an x here, I'm going to put a 2. So we work through order of operations. This is 2 times 4 minus 2, so 8 minus 2, which is 6. So our output value is 6. And we get a point at 2, 6 with our input-output relations. We could also find out what is f of minus 3. And that would be 2 times minus 3 squared minus a minus 3. So again, order of operations says we need to do the power first. And then we're going to change that to a plus 3 because minusing a negative. So 18 plus 3, which is 21, is our output. And so we have the relation minus 3, or the function minus 3, 21. Now you'll notice there's something interesting going on here. Whatever's in parentheses is replacing the x wherever I see it. So one of the things we can do is we can start with a function, f of a. Notice I changed it to a capital F. We can use any letter we want for our functions and it doesn't change. And we can also change our independent variable. But we know what our independent variable is because it's what's inside the parentheses. So what if I wanted to find capital F of a plus 1? So I'm going to take whatever's inside the parentheses, and I'm going to replace the a that was there before with whatever's inside the parentheses, so a plus 1. And now we don't like the parentheses, so we're going to distribute, and then we combine like terms. And we notice that we've changed. Instead of being 3 minus 2a, we're now 1 minus 2a. And so we've created a new function by plugging something different in. Now, while we're here, I also want to talk about just a little bit of a difference between the following. So here, I'm going to start with f, and wherever I see an a, I'm going to replace it with an a. And then I'm going to add f again. But wherever I see an a, I'm going to replace it with a 1. So we get 3 minus 2a plus 3 minus 2, combine like terms, and we get 6 minus 2 is 4 minus 2a. Notice this is different than what we had before because the plus is between two different functions instead of inside the parentheses, and that makes a big difference as we're evaluating these functions.